So today I want to talk to you guys about patterns and linear functions. And just so you know, looking at your notes, yeah, it's going to be a lot of definitions, but it's not wordy, all right? It's not very lengthy. Tomorrow in class, we'll actually break down the patterns and see if it is or is not a linear function. So very first thing is an independent variable. This determines the value of other variables. It does not depend on another variable. So it's your x. We're going to be graphing a lot, and it is your x. The x variable doesn't depend on anything. It can stand on its own. So one thing is time. Time is almost always going to be on your x axis, all right? You don't need anything else to determine time. Time just happens. The other one is dependent variable. This changes in response to another variable. So it depends on the independent variable. This is your y, all right? This is your answer, basically. What the y is depends on the x, all right? You can't have y unless you have your x. So for those of you guys that babysit, how much money you make depends on how many hours you babysit. All right, y is the dependent. Inputs. These are the values of the independent variable. This is what you put in. All right, so using the babysitting example, how many hours are you willing to put in babysitting? 4 hours, 2 hours, 30 minutes? That's what you put in. And then the output, that's the values of the dependent variable. That is what comes out. That's the result. Those are the answers. Well, if I babysit for 2 hours and I get $10 an hour, what's my output? Your output is $20. So a couple examples so you know exactly what I'm talking about, because we're not going to spend time in class talking about input and output. What is the output of y equals 2x plus 7 if your input is 9? So all we need to do, just bear with me here. Alright, so all we're doing is substituting. Instead of 2 times x, my input is 9. Alright, and my input is my x variable, so I'm replacing x with 9. If I plug that in, then what's my output? My output is going to be 25. Alright, another example here. You can have it in table form. What is the output of the following table? So if my equation is 3x plus 4, it's the same exact thing. All you have to do is substitute. So 3x plus 4, substitute in 1 for x. 3 times 1 is 3, plus 4 is 7. Then substitute in 2. 3 times 2 plus 4. So you're going to get 6 plus 4, which is 10. 3 times 3 plus 4, 9 plus 4. And then finally 3 times 4 plus 4. So you're going to have 12 plus 4. Right? We're going to be using the table method most often. So a function is a relationship that shows each input, everything that you put in, has exactly one output. You might have had in maybe elementary school like a function machine. You may have done something like that. This is a similar drawing. Your x is what you put into that equation, 0, then 1, then 2, then 3, and then what comes out are the answers. And then a linear function, pay attention to the first 4 letters in that word, L-I-N-E. It's a line. A function whose graph is a non-vertical straight line. So everything in that picture that you see, those are all different types of linear functions. They're all straight lines. So last question for you. Which graph is a linear function. So look at it, and then the question will pop up here. All right. Okay, should have answered it by now. So I will see you tomorrow. We're going to look at some patterns in depth and write equations for them, make tables, make graphs, and see if it's a linear function. All right, see you then.